Let's explore a function that will process a list of numbers recursively. Here we have a function named count, and the purpose of count is to count the number of items in a list. The way that we start reading a function is we want to take a look at what are its parameters. Well, in count's case, count has a single parameter named list, and its type is a list of number values. So this will be a function that we give it a list of number values, and its return type is going to tell us what it will give us back in exchange. So when we call count with a list of numbers, it's going to give us back a number, and that number is going to be however many elements exist in this list. One of the first important rules that we need to know about functions is that when we recursive functions that process a list is that typically the case we care about stopping this recursion is when the list is empty. When that list is equal to null, this is our base case. And our base case is when we stop calling this function recursively. Our work is done. We've reached the end of this list. Another way of thinking about this intuitively in this case is if the point of this function is to count the number of elements in a list, and we give this function an empty list, we would expect that an empty list has 0 elements in it. The recursive case can be found in our else here. So here is where we call count recursively, and something really important is happening with this argument. Notice that we are changing this argument in some way. We're not saying count the same list, we're saying count the rest of the list. And remember, rest is a function that will give us back a list excluding the first element of the list. So every element after the first element of the list. Intuitively, this is like working your way through a line. Each time we call count, we are focused on the very first element in that list, and then we are going to call count recursively on the rest of that list. We're going to move through the line one by one until finally we reach the end of the line, the empty list, and we'll call the base and we'll return 0 because that's our base case. How might we actually use this function in code? Well, let's imagine a main function that looks like this. And let's trace through this. Let's not jump to any assumptions here on how this is going to work. Let's trace through this as if the computer would. Let's put on our CPU hat and work through this line by line. So in all of our programs, we're seeing this call to main at the very bottom. And this is what's sort of causing our program to jump into main and start evaluating. So when we jump into main, I'm going to set up some space in my computer's view of the world. So here is main in my computer's view of the world. This is main with no arguments, right? So over here in the orange, we're going to imagine this is what the computer can see at any given time when this program is running. And one of the important things that we need to know is that a computer can really only be doing one thing at a time in our classical model of how we imagine computers to work. So here, the line that we're currently working on is let nums be a variable that can hold a list of number values. So this is how we declare a variable that can hold a list of number values. And when this line of code is executed, when the computer runs this line, what it's going to do is it's going to reserve some space in the computer's memory. And I'll use this side of the screen to refer to what are the variables we have available to us in memory. And it's setting up a variable named nums. So let me set up some space named nums here. And nums is just going to be, for now, an empty box. Right? And let me make the box a little bit bigger. This is a variable that can hold a list. So let's imagine that nums it needs a slightly bigger box because it can hold a list that we'll need to write into later. So now this line is complete. This variable declaration line just set up some space in memory and gave it a label. So now we can put things in this space in memory. On this next line, we are seeing the nums variable is being assigned the result of calling this listify function, which is a built-in function with 8, 9 as its arguments. Now this is a function call, just like we're about to evaluate later, but what's kind of interesting about this function call is it's going somewhere and we don't really know what it's doing, we just know what it will do for us. This is one of the beauties of functions. We can think of them kind of like black boxes. We're going to give you some inputs and you're going to give me back some output, and I don't really need to know how you do that. It turns out this is just a recursive function that uses the cons function in a special way, but when listify comes back, it's going to give us back a list that will have 8 followed by 9 followed by null in it, right? So Listify with 8, 9 as its arguments will evaluate to a list with 8, 9 null. And what we're saying is take that list and assign it to the nums variable. Right? So take that list and assign it to the nums variable. So the nums variable in memory is now going to be 8 followed by 9 followed by null. All right. We're done with this line of code. We've completed this assignment statement. We're ready to continue on to the very next line. So the very next line is print the count of nums. So this is what the computer is going to try to resolve and figure out. So we're going to print the result of calling the count function with nums. So the first thing that the computer is going to do is it's going to substitute. And it needs to figure out, well, what is nums? Well, nums is the list of 8 followed by 9 followed by null. I have to excuse the strange notation here, but just trying to fit this all in. So 8, 9 null is being passed as an argument to count. Well, count is a function call, so we're going to need to drop a bookmark here. And ultimately, we're going to be jumping into the count function. So let's set up some space to figure out, well, what is the result of this count function call? Well, what are we calling count with? We're calling count with the list of 8, 9, null. All right. Now, when we make a function call, the very first thing that happens is we need to assign the arguments of that function call to the corresponding parameter. So this parameter list we think of as a special variable in this function call. So list is just a special variable. We set up some space for it. We know that its type is also a list of numbers, and that matches what we were giving it. So nums, notice, was also a list of numbers. So this is okay, the types match up. And what are the actual values we gave it? Well, this list is 8, 9, null. All right. So now that we have assigned to this list parameter the argument that we call this function with, we're ready to begin our work. So we're going to see if list is equal to null. So if list is equal to null. And this is what the program is, the computer is going to evaluate next. Well, list is 8, 9 null. And we know that 8, 9 null is not equal to null. So this if expression is going to evaluate to if false. If false, we know, is going to cause this if statement to skip the then block, and it will evaluate this line of code here. So let's take a look at what will happen when the computer evaluates this line of code. So this line of code is return 1 plus the result of calling count on the rest of the list. All right, I'm not going to substitute this list in for this list variable here, 8, 9. We can just imagine what is the rest of this list where the list is 8, 9. The rest of the list where the list is 8, 9 is just the list 9 followed by null, right? So this is what that would evaluate to. And now we see that we've reached a recursive function call. What is the count of the function? What is the count of the list 9 followed by null? Well, in order to figure that out, we need to make this function call. So what do? We drop our bookmark and we set up some space for the function call of count of the list 9 followed by null. And let me delete my scratches from over here. We're about to make a function call, and we know that when we make a function call, the first step that we need to do is take the argument of this function call and assign it to the corresponding parameter. Well, a parameter is just a special variable that each function call is going to have defined inside of it. And if we want to assign this argument to the variable, the parameter list, we know that for the purposes of this function call, the list has the values 9 followed by null. All right, we've assigned our argument to our parameter, and we're ready to begin thinking about this function call. If list is equal to null, so let's think of what happens in the computer's eye when this gets evaluated. So the line of code that the computer is going to try and evaluate is if list is equal to null, and list is going to be substituted with the list variable stored in this function, so 9 null. And 9 null is not equal to null, so this will be false. And what we know about the if statement is if the condition, the expression in this if statement is false, then we will skip over the then block and we will evaluate the else block. So the computer is going to move to the very next line, and the very next thing it's going to try and figure out the result of is this return statement. So what is the value, or the result of saying return 1 plus count the rest of list? All right. Well, once again, the list that we have currently is 9. The rest of the list of 9 null is just null, right? So the rest of this list is null. And now when the computer is trying to evaluate what is count null, this is a function call. So what is it going to do? It needs to drop a bookmark here. And let's set up some space to figure out, well, what is the result of calling count and with an argument of null, or the empty list? Well, to call count of null with the empty list, the first thing we need to do when we call a function is assign this argument to our parameter list. This list parameter is just going to be a special variable that is going to be defined inside of this function call. And it's going to be assigned null because that was what we called the function with, right? So this function call is what is the result of calling the count function with the empty list. Notice that as we make these recursive calls, we have the same parameter list, and each of these function calls has its own understanding of what it's being assigned. And it keeps track of this. The computer knows at any given point, at any given function call, what its list value is, and it's separate from all the others, and everything's fine and happy. So we have assigned our arguments to parameters. The list parameter has been assigned, and we're ready to think about, well, let's be the computer, and through the computer's eye, what happens next? We see if list is equal to null. And when we try and evaluate this, the first thing we need to do is substitute what is this list variable. Well, list is just null. What do you know? We've reached our base case. If null is equal to null, null is equal to null, that's true. And when we have an if-then statement where the expression is true, then we are going to go to the else block. We're not going to do what's in, we're going to go to the then block. We're not going to do what's in the else block. So the very next line of code that we need to evaluate for count of null is return 0. All right. The base case, we don't have any more recursion to do. We're ready to work our way back to the main function. We know that when we reach a return statement, what we're saying is return 0 to wherever this count null function was called. Another way of saying that is return 0 to our bookmark. So 0 is going to replace where we called count null and left the bookmark. So the bookmark was down here, and we're going to replace this count null with 0. So this is going to be substituted to be 0. Right? And now that we've returned, we can kind of forget all of the work we had to do in order to figure out what was count null. Right? The computer is going to say, you know, I don't want to keep track of this. I'm going to just return back to this count 9 null function where I still have some more work to do. I need to add 0 to 1. Good news is this is pretty straightforward. This will just result in a return 1 statement that the computer needs to evaluate. When the computer gets to a return statement and it has boiled the expression that is trying to be returned down to a single value, it's going to jump through those same steps again. And we're going to ask ourselves, all right, we're going to take this number, this return expression, and substitute it back down where we left our last bookmark. Well, the last bookmark was right here. When we called count 9 null, that brought us into this count function. So we're going to return 1 to this point. So we're going to substitute count 9 null with the value 1. And we're done with this function call. We can erase all of the work we had to do to get into, to figure out what was the count of 9 followed by null. Now we have a return statement in the count 89 null function where we need to evaluate, well, what is return 1 plus 1? This is pretty simple arithmetic. We've reached an expression that is return 2, so we take that 2 value and we're going to return it to where this function was called. So count 89 null was called at this last bookmark, count 89 null. So we are going to substitute count 89 null with the value 2. And we are done with the function call of count 89 null. And what do you know? We're back in the main function. We've worked our way through this entire recursive process in the exact same sort of series of steps that the computer would. And we've reached this print statement, and there's no more work for us to do. We're just going to print out the value 2 to our screen, and our work is done. This will feel like quite a bit of tedium for working through a list in this way, and hopefully as you get more comfortable with seeing these steps, you don't have to work through it quite in the same piece-by-piece, step-by-step way that's a little bit slower. But this video is meant to illustrate the exact steps a computer is going to move through and the rules that will be applied in order to process a recursive function like count that works on a list.